Dear students, I myself, Dr. Bharat Parab, discussing problems on topic comparing quantities. First problem. Kamala borrowed 26400 26,400 from a bank to buy a scooter at a rate of 15% per annum, compounded yearly, that is compounded annually, compound interest. Okay. What amount will she pay at the end of 2 years and 4 months to clear the loan? Read this problem and try to understand it and try to understand this solution. See, it says Kamala borrowed 26400 rupees from bank to buy scooter. Important point of this is she had to pay by compounded yearly compound interest. Okay, both these words are very important. She had to pay compound interest and compounded yearly. What does that mean? We will see now. Okay, and the time period is 2 years and 4 months. See, this is very important. Okay, the 2 years and 4 months. So how will you split this? So we will see what she will pay after 2 years using compound interest formula, and remember compounded yearly. Okay, so let us check for 2 years first. Write the formula accordingly, and this is done as follows. Okay, amount A. Okay, this is the formula, and we are calculating amount and not only interest. In case of compound interest, the formula stands for amount, and for simple interest it stands for only interest. Okay, remember this fact. So A equal to P0 into 1 plus R upon 100 raised to N. So A is amount, P0 is principal, in this case 26400, R is rate of interest, and N is number of years. For meanings of this, refer the first slide or first video. Okay, so all meanings are clear there, and now we substitute all these values. A equal to 26400. The moment you know the meanings of all this and how to use this formula, then problem is very easy. See, it is 1 plus 15 upon 100 square, that is 2 is for 2 years. Okay, 26400. Now we take LCM in that bracket and get 100 plus 15 divided by 100 and square of this. So we solve this bracket. 26400 and 115 upon 100 into 115 upon or square. Okay, we split it. We get 26400 and we write here 115 upon 100 and 115 upon 100 just to make the problem easy, and we cancel 0. After solving it, we get 34914 rupees. So this is the amount she will have to pay after 2 years, but 4 months are still remaining, and for this 4 months this amount is principal. Okay, so 34914 is principal for the next 4 months. If you recall the formula of compound interest derivation or the definition of compound interest, you will come to know what I am talking about. This is very easy if you know the compound interest formula or the definition of compound interest, and you can solve the problem very easily. A2 equal to 34914 into 1 plus. See why I have taken 3 year, you will come to know, because 4 months is one third of the year. In a year, 4 months, 4 months, 4 months gives you 1 year. So 4 months is one third of the year, and that is why this T is there. Okay, this T. I'm talking about this three. Okay, if you look at the formula, you'll immediately come to know why this is like that. Okay, and why the n is 1. N is the installment, so we go ahead with the LCM. 34914 into this LCM, okay, into 315 upon 300 and solve it, and final answer you get. This should be the final answer. Three six six 59.7, okay, rupees. So Kamala will have to pay this amount, okay. So after 2 years and 4 months, you know how to split and do it? Yes, she will have to pay so much amount in rupees, okay. Second problem, Fabina borrows rupees 12,500 at 12% per annum. PA stands for per annum, for 3 years at simple interest. Remember, this is simple interest. Okay. And Radha borrows the same amount. Now P is same, P0, for the same time. Now N is also same time period at 10% per annum. Okay, so R changes. Compounded annually. This is simple interest, this is compound interest. Who pays more interest and by how much? You understand this? That P0 for both are same, time period is same, only we have to calculate this by simple interest, and for Radha it should be compounded annually, and by compound interest our rate of interest is also different, 12% for simple interest for Fabina and 10% per annum for Radha, compounded annually. Okay, let us try the solution. If you look at this problem very carefully, that P0 for both are same, so you can compare simple interest and compound interest here. Okay, so Fabina borrows by simple interest, so let us calculate interest paid by her, okay, for 3 years. So we recall the formula of simple interest. I equal to P0 into R upon 100 into N, where P0 is principal, R is a rate of interest, N is number of years. May recall this formula by heart this, or try to solve as many problems as you can, so that you can every time write it and remember it. No need to do any special task for this. Okay, I stands for simple interest. Okay, so we substitute the values. 12500 into R is 12 upon 100 into 3. Now that has become very simple problem. So cancel this 0 and you get it. What is this? Is the interest 4500. This rupees, this is interest. Okay, only interest, remember that. And while paying, she will have to pay principal plus this interest rate, rupees. And the Radha borrows by compound interest. Okay, compounded annually, important point, compounded annually or yearly. Okay, and 10%. So we write the formula amount. See here, this is amount, and above case that was only interest. Remember that point first. Okay, A is equal to P0 into 1 plus R upon 100 raised to N. For full forms of these and meanings of this, refer first slide or in the first video or your books, and you will come to know all these quantities are. Okay, now we substitute them. So equals, now P0 is same. Okay, this is changed from 12 to 10 and 3. Okay, now take LCM. So okay, 12500 into 110 upon 100 raised to 3. 3 is for years, and we'll write another step. A equal to okay, very simple. Now again some zeros will get cancelled. This is cancelled, this is cancelling, and final amount. See, in this case you are getting amount. Okay, 16657.5 rupees amount, and we have to find out interest, who paid more. So interest will be this minus, got it? So this is the interest he paid. Okay, 4137.5. So need to calculate. In above case we have calculated only inside. This is amount minus principal and got interest. Don't get confused in this. And 4500 minus this. So Fabina pays more. Okay, Fabina paid more. Simple answer 362.5. Okay. Another problem. Arif took a loan of rupees 80,000 from a bank. Okay. If the rate of interest is 10%, find the difference in amount he would be paying after 1.5 years if the interest is compounded annually and compounded half yearly. See, this is very nice problem. Okay, see this 80,000 is P0, interest is 10%, and time period is 1.5 years. Okay, and we have to find out the difference when the compound interest was compounded annually and compound interest was compounded half yearly. Okay, so we go ahead for the solution. Read this problem very carefully. Okay, so Arif took a loan of 80,000 from a bank. See here, compound interest is 10 and period is also 1.5 years. Okay, the only thing is, in first case it is compounded annually, and second case it is compounded half yearly. So this is very nice example to see the difference in amount when compound interest is collected or taken annually and half yearly. Okay, compounded annually and compounded half yearly. Okay, so whenever you come across such type of example where interest is compounded annually, I am talking about annually, we are taking this case first. Okay, CI stands for compound interest annually, and the time period is something like half or 4 months or 3 months, like that, then we should calculate for 1 year first. Okay, These are the steps. Remember that if you solve enough number of examples, you will come across such type of examples frequently, and you can solve it very easily. You come to know the hinge in this. So we solve for 1 year first, and then for the remaining half year. So I am writing it for 1 year. A amount A equal to P0 into 1 plus R upon 100 raised to N. Okay, you know the meanings of all these P0, R and N, etc. So I am directly substituting it. 80,000 into 1 plus 10 upon 100 raised to 1. 1 because N equal to 1. We are calculating only for 1 year. Okay. So after cancelling 0, it 80,000 into 1 plus, after taking LCM, 10 plus 1 upon 10, that is 80,000 into 11 upon 10. So we cancel 0 and we get 8,000 into 11 is 88,000. Okay, this is after 1 year, rupees 88,000, 88,000 after 1 year. Again 6 months are left. Okay, so for 6 months we are using compound interest formula. You can go back and see why this formula is like that. You will come to know immediately that A equal to P into 1 plus R upon 200. Remember that this 200. Okay, this is very important when you are calculating for half year. Okay, so this is that formula. I explained it in 2 videos. You can go through it, and we are going ahead. 88,000 will be the principal for the next half year or 6 months. So this is that 88,000 into 10 plus 1 upon 20 plus 1 upon 20, 20 into 21. Okay, now it is simple mathematical calculations. 2 goes and 44,000 goes, and you get 4400. So 92400 rupees. Okay, calculate it yourself again. Now for half yearly compounded, okay, and the formula is, we have written this formula there, but is little change in this. This 2 is there. Okay, 200, and this will be N will be equal to, as there are half yearly, there will be 3 half years. 1.5 year means 3 half years. So N will be 3. See, it's installment. N will be 3. Okay, this is important. Okay, now we cancel zeros. Now after this is just a simple mathematical calculations. These are very easy. Should not make any mistake. Okay, so 80,000 into, now you solve this bracket first. 21 upon 20 cube. Okay, what is half yearly means 3 half years. Now 1.5 year is 3 half years. So unlike that previous example, we are taking directly 3. Okay, see, this is thrice means 21 upon 20, 21 upon 20 into 21 upon 20. We cancel all this 0, all 2. Okay, then 21 into 21 into 21, and that 0 is still there. Okay, so we get 92610. Okay, that 0 is again there, these rupees. So difference will be, you are paying more by compounding it half yearly. Okay, see, 92610 and 92400. So when the amount, when CI stands for compound interest yearly, Okay, so you need to write the final statement, what is given or what is asked. Okay, so amount when ci is added yearly is this, and when after this. Okay, another example, a population of a place increased to 54,000 in 2003 at the rate of 5% per annum. Okay, find the population in 2001 and what will be its population in 2005. That is, in they have given the population in 2003, increase was 5%. Same, though population is taken, it is uh, compound interest problem. Okay, so need to treat it like that. This is a rate, this is, we will see in solution what is this. Okay, 2003, and here 2 years back you have to find out. Okay, very tricky, very interesting and very intelligent problem. Okay, and what will be its population in 2005. Okay, so let us go for the solution. This is very intelligent problem. Though population increase is given, this is a type of compound interest problem. Okay, so see, can you correlate in this? An increase to 54,000 in 2003. Okay, so read it very carefully. He wants population in 2001, 2 years before that. Okay, so you have a population after 2 years, so you need to find out P0. Okay, if 54,000 is a population after 2 years, see I am writing here amount after 2 years from 2001 to 2003 is 54,000. Okay, and rate of increase is 5%. Okay, so a equal to p0 into 1 plus r upon 100 raised to n. Okay, using compound interest formula. Okay, now in this case a is given amount after 2 years. Okay, and p0 is to be found. Okay, found out. Okay, so now you can substitute the values. R you know is 5%, N you know is 2 years. Okay, now this has become very simple problem, that 54,000 equal to P0 into 1 plus. The moment you write this correctly, then it is just a mathematical expression. Okay, write these values correctly and then you face no problem. Okay, now cross multiply. So 54,000 into 100 into 100, that square is there, then 105 into 105, very simple now. Okay, that is, this is P0. Try to solve it and you get it. Then you multiply or divide by 5, you get 48979.6, that is approximately 48980. Okay, we take nearest number, as it is population, cannot be in fraction. So population in 2001 is 48980. Okay, now the next part, what will be its population in 2005? Okay, if you take this as your P0, then n will be 4, and if you take 54,000 as your P0, n will be 2. Okay, we are taking it 54,000. because that is given data and this is answer by us. So A equal to P0 into 1 plus R upon 100 raised to n. Here P0 is 54,000. Okay, that is in 2003. So we are calculating for 2 years, so n equal to 2. Now we are substituting the values. 54000 into 1 plus 5 upon 100 raised to 2. Okay, now this has become a simple expression in maths. Okay, now the A equal to 54,000 into 105 upon 100 into 105 upon 100. Now your 00 gets cancelled, and this is your answer. Okay, after cancelling this 2 and all this, 595335. Okay, population in 2005. Okay, so we write the final statement. Population as you have to answer this. Population in 2001 will be 48980, and population in 2005 you need to write this. Okay, is 59535. That's all.